Hey guys, it's Mr. Tracy. We are going to continue moving forward with Unit 11. All right. And at the top of the page, you should see a word that probably scares some of you, but should definitely be familiar to all of you, since you all took geometry, and that is trigonometry. Before we move forward with the Algebra 2 part of trigonometry, we have to go over some of the basics that you learned last year and kind of refresh your brains. All right, so today's just going to be a review lesson. There might be a couple of things we'll talk about that you haven't seen before, but for the most part, this should all be stuff that you've seen. All right, so first things first, we have to talk about the trigonometric ratios. I know it says sin, and I know it says cos, and I know it says tan, okay, but those are all abbreviations for sine, cosine, and tangent, okay? That's how you say them. Sin is not a thing, at least in math it's not a thing. Cos is also not a thing. It's sine and cosine, and it's tangent, all right? So if you're going to refer to them that way. This little symbol, I don't know if your teacher showed it to you last year, okay, but it's actually a Greek letter in the Greek alphabet. It's called theta, okay, and it's a Greek letter that is used to represent an angle measure. All right, remember trigonometry basically deals with right triangles and angles, and we can use those things using these trigonometric ratios to solve for the length of sides of right triangles. And that's what we're going to go over today. All right. So, all of you, and I'm sure you've heard this before about that woman who used to like to solve right triangles back in the day, and her name was SOHCAHTOA. All right. Obviously, that's a fake story, and we just made that up because it's easy to remember, and it's a nice little way, a nice little mnemonic device to remember the trig ratios of sine, cosine, and tangent. Now, what the heck does that mean? All right. What SOHCAHTOA means is that the sine of an angle equals opposite over hypotenuse. The sine of an angle equals opposite over hypotenuse. Now, what the heck does that mean? I'm going to draw a little triangle over here. Like I said, trigonometry deals with right triangles, okay? And the right triangle has three sides, okay? And we're always going to refer to those sides based on whatever angle theta is, okay? So, first things first, if we were labeling this triangle based on theta, okay, there's three different sides. There's an opposite, there's a hypotenuse, and there's an adjacent. The hypotenuse never changes. The hypotenuse is always the longest side of the triangle, and it's always the one that's across from the right angle. You guys should remember that from last year, okay? This is the hypotenuse in this particular triangle because it's across from the right angle. The side that's across from whatever reference angle we're talking about, or whatever theta we're talking about, the side that's opposite that angle, we call, guess what? The opposite, because it's across from theta. Okay? Hypotenuse is across from the right angle. The opposite side is across from the theta angle. And that just leaves the adjacent. Adjacent in the English language means next to. So, when you're labeling a triangle, the opposite is across from theta, the adjacent is next to theta, and then the hypotenuse is always across from the right triangle, from the right angle. All right. So the sine of the angle equals the opposite over the hypotenuse. That's the SOH, so part of SOHCAHTOA. Cosine, if you look at SOHCAHTOA, cosine equals adjacent over hypotenuse. That's the K. And last but not least, the tangent of theta, tangent equals opposite over adjacent. Okay, we're going to use those a little bit. On your homework, you're going to use them, and then down here at the bottom, we're going to use them too. But but that should all be review. You guys learned that last year. This part might be new, except for some of you that had me for advanced topics last year. We did this. This is the procedure for rationalizing denominators. What the heck does that mean? Rationalizing a denominator just means that if there's a radical in the denominator of a fraction, in mathematical terms, that looks gross to us. Okay, I want you to see a radical in the denominator and say, ugh, that's gross. Okay, and there's a procedure to get the radical out of the denominator and write a fraction that is equivalent to this, except we're going to get rid of this radical down here. The way that we do that is we multiply the numerator and the denominator by the radical that's in the denominator. Well, what's the radical in the denominator here? 12. Okay, so we are going to multiply both the top and the bottom by radical 12. Now, why do we do that? What happens when you multiply the same radicals together? Well, let's do that over here really quick. If I took the square root of 5 and I multiplied it by the square root of 5, no, I'm going to change that actually. If I took the square root of 25 and I multiplied that by the square root of 25, what would that equal? Well, the square root of 25 is 5. The square root of 25 is 5. And 5 times 5 is 25. Weird. What if I did the square root of 36 times the square root of 36? Well, square root of 36 is 6. Square root of 36 is 6. And 6 times 6 is 36. So what happens when you multiply the same radicals together? Basically, the radical just disappears and you're left with what's underneath the radical. Okay, that's going to help us rationalizing the denominator. Now remember, multiplying fractions, you just multiply across. 1 times radical 12 is radical 12. And 6 radical 12 times radical 12, well, like we just said, when you multiply the same radicals together, the radical just disappears. So this is 6 radical 12 times radical 12. Radical 12 times radical 12 is just 12. And then we're multiplying it by this 6 that's out here in front. And then that ends up being 6 times 12, 72. So I get radical 12 over 72. Unfortunately, we're not done because radical 12 can definitely be simplified. Remember, if we broke this into the square root of 4 times the square root of 3. So square root of 4 is 2. Radical 3, we leave it. So we have 2 radical 3 over 72. And still we're not done. This isn't fully simplified because I can, since these two numbers don't have a radical on them, I can simplify them and divide them both by 2. 2 radical 3, if I divide it by 2, the 2 disappears. I just get radical 3. And if I divide 72 by 2, that's 36. Okay, all I did was I divided by 2 up here and divided by 2 down here. And I get radical 3 over 36. And if you use your calculators, radical 3 over 36 and 1 over 6 radical 12, these are the same exact decimal. Okay, they're completely equivalent in every way. Right. So any time that we're working with trigonometry and we're left with a radical in the denominator, we just have to take it one final step. All right, let's try some exercises. Using the triangle to the right, okay, there it is, find each of the following trig ratios, rationalize any denominators if necessary. All right, so we have to figure out what's the sine of theta, what's the cosine of theta, what's the tangent of theta. Well, where's theta in this triangle? Theta's right there. Okay. First things first, I always like to label my triangle. Okay. I like to label the hypotenuse first because the hypotenuse never changes. Okay, the hypotenuse is always across from the right angle. So in this case, the hypotenuse is radical 5. They're referring to this side as the hypotenuse. And then the opposite and the adjacent, that matters on where theta is. Theta could have been this angle or this angle. It's one of the two acute angles in a right triangle. In this case, it's here. So we're going to label the opposite and the adjacent based on theta. What do you think this side would be considered in relation to theta here? Would that be an opposite or would that be an adjacent? It would be an opposite because it's across from theta. It's not touching theta, it's all the way across here, across the way. And that just leaves this side here, which is definitely an adjacent because it's touching theta. Okay, remember adjacent means next to. All right. Now, what do I know about sine? Well, from up here, sine, that's the so part in SOHCAHTOA, sine equals opposite over hypotenuse. All right, well, sine equals opposite over hypotenuse. Well, what's the opposite side in this triangle? No, yeah, opposite is 1. Hypotenuse is radical 5. Opposite over hypotenuse, 1 over radical 5. Does that look gross? It should. 1 over radical 5, that is not rationalized. We have to get rid of that radical in the bottom because it looks gross. So, what do? It says rationalize the denominator by multiplying the top and the bottom by the radical in the denominator. The radical is 5, so we're going to multiply the top by radical 5 and the bottom by radical 5. And 1 times radical 5 is radical 5. That's okay. Radicals in the top are perfectly fine. And radical 5 times radical 5 is 5. So, fully rationalized, the sine of theta is radical 5 over 5. All right, what about the cosine of theta? Cosine from SOHCAHTOA is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. Okay, so now I'm going to go back over to my diagram over here. Hypotenuse is radical 5. The adjacent, I don't have a measurement here. I don't know how long this side is. The question is, can I figure out how long this side is? Absolutely. Does anybody remember a way that if I have 2 sides of a right triangle, think back to last year, and I need to find the other side of the right triangle, there's a particular theorem that rhymes with Pythagorean. Pythagorean theorem. You guys remember? A squared plus b squared equals c squared. Okay. Now, the c is always the hypotenuse. The a and the b are the 2 legs of the right triangle. So if I wanted to solve for, we'll call this x over here, if I wanted to solve for this side, okay, I'm going to use a squared plus b squared equals c squared, with the c part definitely being radical 5. Okay, a squared plus b squared equals c squared. A squared plus b squared equals c squared. All right, now x squared plus 1 squared is 1. Radical 5 squared, well, think about it. Radical 5 times radical 5, we know that the radical just disappears and we're just left with 5. Subtract 1 from each side, and I get x squared equals 4. And then I'll take the square root of both sides and I get x equals 2. It's really plus or minus 2, but I know that for a fact that this cannot be negative 2 units long because it's a measurement. So this side is 2. All right, cool. So now I can fill in. All right, I know that the cosine of theta is adjacent over hypotenuse. The adjacent is 2. The hypotenuse is radical 5. So it's 2 over radical 5. Should I leave my answer like that? No way, Jose. I have to rationalize it. The radical in the bottom is gross. So I got to multiply by radical 5 over radical 5. And I get 2 radical 5. 2 times radical 5 is 2 radical 5. And radical 5 times radical 5 is 5. 2 and 5 do not have a common denominator or common factor, so I can't divide anything out. So that's the simplest form. Cosine of theta equals 2 radical 5 over 5. And last but not least, tangent of theta. That's the TOA part. Tangent equals opposite over adjacent. I'll go back to pink. Opposite over adjacent. Opposite is 1. Adjacent is 2. Opposite over adjacent would be just 1 over 2. And we can't simplify that any further, so we are done. And that's how you figure out the trig ratios when you're dealing with any right triangle. All right, moving on. All right, exercise number 2. Suppose cosine of theta equals radical 6 over 5. Find the exact value of sine of theta. So whenever you see the word exact, that means they want it in terms of radical. They don't want your answer to be in decimal form. They want it in fraction form, and they want you to leave the radical. Okay, so suppose cosine of theta is radical 6 over 5. Go back up here. We're dealing with cosine, so what's cosine? Cosine is adjacent over hypotenuse. So I know for a fact that radical 6, since cosine is adjacent over hypotenuse, I know radical 6 is an adjacent. I know 5, is a hypotenuse. I'm going to draw a diagram of a right triangle. Here's my right angle, okay? Theta can be either one of the two acute angles. It doesn't really matter. I'm going to put my theta down here, okay? So I know 5 is the hypotenuse, and the hypotenuse is always across from the right angle, so that's 5. And I know radical 6 is the adjacent, so I have to figure out where's radical 6. Is it going to be this side over here, or is it going to be this side down here? Radical 6 is an adjacent, so which one is adjacent to theta? Is it this one all the way over here, or is it this one that's touching theta? It's this one down here. Adjacent means touching or next to. It doesn't mean touching, it means next to. Alright, so here's my hypotenuse. Here's my adjacent, which means this side all the way over here has to be the opposite. Now, I don't know how long this side is, but I'm going to need to figure that out, because this is saying sine of theta, and I know that the sine of theta is opposite over hypotenuse. So I'm going to need to figure out how long is that opposite side over here. How am I going to do that? Pythagorean theorem. Remember, the c is always the hypotenuse, so it's going to be a squared plus b squared equals c squared. Radical 6 squared plus x squared equals 5 squared. A squared plus b squared equals c squared. Radical 6 squared is just 6. 5 squared is 25. Minus 6 minus 6. I get x squared equals 25 minus 6 is 19. And then when I take the square root of both sides, I get x equals radical 19. Like I said, since they want the exact value, I'm not going to put this in my calculator and get a never-ending decimal. I'm just going to leave it as radical 19. That's perfectly okay. So I know this length here is radical 19 units long. Okay. Now, what's the ultimate goal that I was being asked to do? I was being asked to find the value of sine of theta. So I know sine of theta is opposite over hypotenuse. Well, what's the opposite in our diagram? Radical 19. What's the hypotenuse in our diagram? 5. So I get radical 19 over 5. That's what the value of sine of theta is equal to. We good? Beautiful. Moving on. Oh, Regents question. Here we go. Love these questions. If the sine of x, remember, whenever they're talking, the number or variable that goes next to the trig function, whether it's sine, cosine, or tangent, the value that is next to that is always an angle. Okay, so x is an angle. That would be our theta. Okay, equals radical 5 over 3. Find the value of cosine of x. So we're doing basically the same thing that we did last time, except we're finding the cosine of x now. So I'm going to go ahead and draw my triangle. It's a right triangle for sure. All right. I also have seen SOHCAHTOA written this way, if you prefer. So, ka. So, oh my goodness gracious. Hush your mouth. I think the mailman's here or something. I lost my train of thought. Either way, you want to write SOHCAHTOA to help you remember. That works here. So, sine of x equals radical 5 over 3. Well, sine is opposite over hypotenuse, so that means that radical 5 is definitely an opposite, and 3 is definitely my hypotenuse. Okay, x is my theta. Okay, so we'll put that in one of the acute angles. All right, 3 is the hypotenuse. Remember, the hypotenuse is always across from the right angle. So here's my hypotenuse, and radical 5 is the opposite. Okay, so they're talking about, remember, opposites and adjacents are we label based on the reference angle here, the x. Okay, so what's the opposite of x? That would be this side over here, which is radical 5. All right, 3 is definitely a hypotenuse. Radical 5 is definitely an opposite, which means this side down here would be considered what? An adjacent. All right, what's our ultimate goal? Find the exact value of cosine of x. Well, I know for a fact that cosine of x is going to be adjacent over hypotenuse. So remember that from SOHCAHTOA. So I need to figure out what's the length of the adjacent and the length of the hypotenuse. Hypotenuse is 3. The adjacent I don't know yet. Can I figure out how long this side is? For sure. Pythagorean theorem. A squared. We already used x, so I'll call this y. Or b, whatever you want. A squared plus b squared equals, remember, c squared is always the hypotenuse, and that definitely matters. Right? So, radical 5 squared plus, we'll call that y squared, equals 3 squared. Radical 5 squared is 5. 3 squared is 9. Subtract 5 from both sides. I get y squared equals 4. And when I take the square root of both, I figure out that my adjacent y is 2 units long. So this side down here is 2 units long. This side is radical 5 units long. This side is 3 units long. All right. Cosine is adjacent over hypotenuse. Well, my adjacent is 2 units long. My hypotenuse is 3 units long. Adjacent over hypotenuse. 2 over 3. 2 is my adjacent, 3 is my hypotenuse. So the cosine of x equals 2/3, or 2 over 3. Dunzo. Okie dokie. Moving on. Ooh, inverse trig. Love it. If you know 2 sides of a right triangle, you should be able to use the inverse of one of our trigonometric ratios to solve for any missing angle. So we were using to solve for missing sides. You can also figure out the measure of the angles if you're given the sides. You can go backwards. Okay? Now, the way that I do that is, they want us to give the measure of the acute angle theta to the nearest degree. Okay, so we're going to be rounding to the nearest whole number here. All right, where's my calculator? Here it is. Oh, Old Faithful. I've had this calculator since I was in college, which was 1 billion years ago. Okay, so the sine of theta equals 3 over 10. So I need to solve for theta. That's what we're being asked to do. It says find the measure of theta. So remember, just like if you were solving, I don't know, 3x plus 7 equals 25, okay? And it said solve for x. What does that mean? That means isolate the x and get it by itself. And then we would subtract 7 and get rid of the 7, and we would divide 3 and get rid of the 3, okay? And we would be left with x equals something, okay? Same thing here, okay? I have to get rid of this sign. So I'm just left with theta equals, and then a measurement. All right? So I have to do the opposite, or the inverse of sine. Think about it like this. How would you know, I'm sure all of you know that in order to solve this equation up here, I would have to subtract 7 first. Why am I subtracting 7? Because this says plus 7, and subtraction is the inverse of addition. And then what would the next step be? The next step would be to divide by 3. Why? Because 3 times x, I have to do the opposite of times, or the opposite of multiplication, which is division. Because multiplication and division are inverses of each other. So what's the inverse of sine? You guys remember this? It's actually called arc sine. And it looks like this. Sine -1. And whatever you do to one side of an equation, you do to the other side of the equation as well. Okay? So if you do the inverse of sine to sine, they cancel out, and you're left with theta. And then you have to take the arc sine of 3 over 10. Sine -1, 3 over 10. Now, how do I do that? Well, if you go to your calculator, okay, you have arc sine, arc cosine, arc tangent with the little -1 on top of it. Those are all the inverse trig functions. So if I wanted to find the arc sine of 3/10, I would press second sine 3 over 10, like that. And I get 17.45. 7, 6, 0, 3, 1, 2, ba 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 ba. What are we rounding to? Round to the nearest degree, so that means round to the nearest whole number. So 17.4, that tells me I have to round, not up, but I would keep the 17 the same. So 17 degrees. All right. Over here, how do I get rid of tan? I have to solve for theta. I have to get rid of tan by doing the arctan of both sides. So I get theta equals the arctan of radical 3 over 3. Easy enough. Second tan, radical 3 divided by 3. And I get, 30? Is that right? Hold on a second. Yeah, that's right. I thought I did something wrong. I didn't remember that it came out to a whole number. Easy enough. 30 degrees. Coolio. Over here, cosine. So I have to do the opposite of cosine, or the inverse of cosine, which is arc cosine of both sides. These will cancel. And I get theta equals the arc cosine of 0.5. Easy enough. The calculator will do the hard stuff for us. Second cosine, 0.5. Oh, another whole number. Sick. 60. We don't even have to round degrees because it's an angle. All right. Last but not least, I have to do the arctan to both sides. These will cancel, so I'm just left with theta equals the arctan of 3, which my calculator tells me is 71.56. So I would round that up, and I get 72 degrees. I just thought of something I wanted to say, and I forgot. Maybe it'll hit me. Moving on. My wife's shaking her head at me. I don't know why. Okay, two more. Angles of elevation and depression. Okay, Amelia is standing on the beach looking up at a lighthouse whose base is 650 feet from where she is standing. If the angle of elevation from where Amelia is standing to the top of the lighthouse measures 52 degrees to the nearest foot, how tall is the lighthouse? Well, for all my trig word problems especially, I like having a diagram personally. I would say you would have a much higher chance of succeeding if you draw out a diagram. So that's what I'm going to do. I'm going to draw Amelia. Here she is. Okay, she's on the beach. She's looking up at the lighthouse. I'm bad at this. Oh my god. Lighthouses usually have stripes. I know I'm getting very detailed. You don't have to get this detailed. You can just draw a triangle. I think that's what a lighthouse looks like. Here's the light shining out to the sea. Okay, here we go. So she's looking up at the top of the lighthouse. I guess I should have made this straight, but either way, this is supposed to be a right triangle. Okay. All right, now we have to fill in some spots. Well, anytime you're given one of these word problems, it's painting a picture of a right triangle. Okay. So if you want to just draw the triangle, that's fine. I like drawing pictures. Where's my right angle? It would definitely be this one here. All right. So, looking up at a lighthouse whose base is 650 feet from where she is standing. Okay, so where is she standing? Here. Where is the base of the lighthouse? Here. So where do you think 650 goes? If she's standing here and the base of the lighthouse is here, where does 650 go? You got it. This is 650 feet here. If the angle of elevation where Amelia is standing to the top of the lighthouse measures 52 degrees, so it's definitely an angle that I'm going to put 52 degrees at. And which angle do you think is going to be 52 degrees? It's definitely not going to be this one because this is our right angle here. Okay. Think about what elevation means. Okay. Where have you heard the term elevation? Like an elevator. Okay. So whenever you see the term angle of elevation, it's the angle of looking up at something. Okay. So where is Amelia and where is she looking? Amelia's here and she's looking up. So the angle is in here where Amelia is. 52 degrees goes right here. What is our goal? To the nearest foot, how tall is the lighthouse? This is definitely how tall the lighthouse is, this measurement right here, so we'll call that X. All right? All right. How do I solve this? 52 is going to be my theta. That's going to be my reference angle, the angle that I'm dealing with. Okay? So, we're going to look at the information that I have. I have 650, and I need to solve for X. So these are the only two sides I really care about right now. And we're going to label them based on the reference angle. What would X be considered? It's either an opposite, an adjacent, or a hypotenuse. Well, it's definitely not the hypotenuse. The hypotenuse is this side over here because it's across from the right angle. X would be considered the opposite because it's across from the angle that we're working with. Which leaves 650 is definitely my adjacent. Alright, so I need to solve for the opposite and I'm given the adjacent. Which trig function is it sine, cosine, or tangent that deals with opposite and adjacent exclusively? It's tangent, right? the tangent of an angle equals opposite over adjacent. That's the TOA part of SOHCAHTOA. And now I'm just going to pop in my information. Tangent of theta, what's the angle I'm using? 52 degrees, tan 52, equals opposite over adjacent. Opposite is x, adjacent is 650, and I need to solve for x. And that'll tell me how long the, or not how long, how tall the lighthouse is. How do I solve this? Do you remember from Algebra 1? From geometry? Here's the way that I taught it, and for those of you that were lucky enough to have me last year, I always liked to put it over a 1. The reason I like to do that is because a lot of kids, when they see a fraction is equal to a fraction, they love to cross multiply, which is exactly what I'm going to do here, okay? Most kids are pretty good at remembering that, so I like dealing with it as a fraction. That's the way that I did it when I was in high school and the way that it was taught to me, and it just makes sense to me. You may not have learned it that way, but if you remember a way that's easier for you to do it, that's fine. But I like thinking about it as a proportion, and with a proportion I can cross multiply. So I have x times 1 is x equals 650 times tangent of 52. 650 times tan 52. And I did the hard part. Calculator is gonna tell me what is 650 times tan 52. 650 tan 52. If you just put it out in front like that, it's going to multiply them together. If you don't believe me, there you go. Okay, whether you put the multiplication sign or not. And we get that the lighthouse is 831.9620609 feet high. Let's see, what do we have to round to? It says round to the nearest foot. So 831.9, I would round to 832 feet. Dunzo. Any questions? All right, moving on. All right, last one. Buckle in. A plane is flying at 31,000 feet and begins its descent, which means it's landing, 125 miles from the airport. If the angle of depression is constant, find its measure to the nearest tenth of a degree. Well, just like angle of elevation is looking up, the opposite of that would be angle of depression, which is looking... Go ahead. Yeah, my wife said down. Very good. Okay, so here's theta. Okay, the plane is looking down at the airport. So this here is theta. Now, that kind of stinks a little bit because here's my right triangle, as you can see. And this angle out here is not inside. It's not one of the interior angles of the triangle. So that kind of stinks. So what are we going to do? Well, I think ad nauseum last year. Shush! You guys probably discussed. Remember these pictures? Parallel lines cut by a transversal. Yes, I'm sure you do, and your teacher spent a lot of time on it. But the main thing that we need to talk about here is this angle in here and this angle in here are equivalent to each other. Whenever you have two parallel lines, which means they never touch, cut by a transversal, excuse me, a transversal, the two alternate interior angles, remember that term? Alternate interior angles are congruent to each other. And congruent is just a fancy way of saying equal. Well, guess what I have here? I have parallel lines cut by a transversal, and I have alternate interior angles here and here. These two angles are always congruent. So I'm going to use theta since I know these two angles are exactly the same, and I'm going to pop theta in here. because now I can use this to help me figure out, what am I being asked to find out? How big this angle is. All right, well, based on my reference angle here, okay, I have 31,000, I have 125. Those are definitely going to help me solve for the angle. What would 31,000 be considered in reference to this angle? It's either an opposite, an adjacent, or a hypotenuse. Definitely not in the hypotenuse. The hypotenuse is this one over here because it's across from the right angle. This is an opposite. It's across from theta, which means 125 is definitely an adjacent. That's a horrible J. There we go. Okay, now look at our picture. We have the measurement of the opposite. We have the measurement of the adjacent. So which trig function, sine, cosine, or tangent, which one of these deals with strictly opposites and adjacents? Well, sine is opposite over hypotenuse. I don't know how long the hypotenuse is, so that's out. Cosine is adjacent over hypotenuse. Again, dealing with a hypotenuse, which I don't know, so that's out. And tangent is opposite over adjacent. I have an opposite, I have an adjacent, so I'm definitely going to use tangent. Tangent of the angle equals opposite over adjacent. Opposite's 31,000, adjacent's 125. Okay, so the tangent of the angle equals, opposite was 31,000, adjacent is 125. I just caught something that's really annoying. This is 31,000 feet. Down here, this is 125 miles. I can't really divide these until I get them to be the same exact unit. I either have to convert this miles to feet, or I have to convert this feet to miles. And in order to do that, I need to know how many feet are there in a mile. That's kind of annoying. And it's something that the Regents uses to kind of trip you up a little bit, but it's really not that bad of a calculation. Okay? If I wanted to convert miles to feet, I need to know how many feet are in a mile. That's actually on the reference table for the Regents, which you don't have to take this year. But the answer to that is there are 5,280 feet in every mile. Dogs. So, if I want to figure out how many feet there are in 125 miles, all I have to do is take 125 and multiply it by 5,280. And that's how many feet there would be in... Can you guys stop? Hey! Enough. Give me 3 minutes, please. 125 times 5,280 is 660,000. So there's 660,000 feet in 125 miles. All right, so I'm just going to rewrite this, and instead of 125, I'm going to pop in 660,000, and we should be good to go. Tangent of theta equals 31,000 feet over 660,000 feet. That's good. I have the same units now. Now I can keep going. All right, I have to solve for theta. That's what they're asking me to do. Figure out how long is, or rather, how big is the angle. So I have to get rid of tan. What's the inverse of tan? Arctan. And I'm going to do that to both sides. All right, the arctan of tan, they cancel each other out. So I'm just left with theta. And then over here, I have to do the arctan of 31,000 over 660,000. And if I pop that in my calculator, 31,000, arctan of 31,000 over 660,000 is 2.6891888977 degrees. They want us to round to the nearest 1/10. So I'm looking at 2.68. I would round that to 2.7 degrees. Hi. All right. If you have any questions, as always, shoot me a message on Remind or on Microsoft Teams, or email me, or I guess those are all the ways. I hope you guys are healthy. I hope you guys are washing your hands, and I will talk to you soon. Have a wonderful day.